Hi guys, this is the last lesson in topic 10, so we have a test coming up over topics 9 and 10. In this lesson we're going to be able to pull out the triangles that are needed in a more complex diagram in order to write some proofs. So when you have triangles in a diagram that are overlapping each other, sometimes the congruent triangle proofs become a little more complicated because it's difficult to visualize which triangles you need in order to look at the corresponding parts. So in this exploration, we're going to use the animation to help us see the two triangles that we need in order to pull out in order to do this proof. So look at question 1 in your notes. You have this figure, but we have several triangles that are involved in this figure. If you look at the given information, you're given AD and BE as being equal to each other, and CD and CE as being equal to each other. We're trying to prove some angles are congruent. In order to prove those angles are congruent, we want to prove triangles are congruent first, and then use CP/CTC in order to say these corresponding parts are also congruent. So if we look at angle CEA, this is this angle right here. And we also have angle CDB, which is this angle right here. So if you'll look at the triangles that those angles are in, that really does help you see what triangles you need to prove are congruent first. So number 1 says, what triangle congruence would help you prove this statement? So on your notes, if you look at the two angles in question, angle CEA is this angle right here. The sides of that angle are sides CE and AE. Those sides, if we pull them and connect them together, you'll see that we're talking about this triangle right here, which is triangle CEA. Triangle CEA. If we look at the other angle, angle CDB, and we look at its sides are CD and BD. So if we connect those two sides, we'll see what triangle we're looking at there. We're looking at triangle CDB. So that is the answer to number 1. Those are the triangle congruences we're needing to prove. We need to prove that triangle CEA is congruent to triangle CDB. Now that's not the end of the proof, that's just a tool to get to proving the angles that we want to prove are congruent. So if we can show that those two triangles, CEA and CDB, are congruent, we can then use CP/CTC to prove that the angles we're wanting to prove are congruent. So visualizing these triangles and their corresponding parts is easier when we kind of pull the diagram apart. So we can see this better in this animation here. So in question number 2, it asks you to redraw the triangles so that they do not overlap. So we can see that here in this, we have the same figure in this animation, and you will see that they will pull out a triangle CEA. So that's what you want to do on the left side of your notes. You want to just draw triangle CEA. We're going to label its parts. So this is vertex E, C, and A down here, and also estimate point D on your figure as well. On the right side of that, you're going to pull out triangle CDB. So we're going to draw that on this other side, CDB, and these don't have to be perfect. You're just trying to get a better visualization of this. So again, we're going to label these vertices. That's vertex C, this is D, and this down here is B. And again, I'm going to estimate point E on the figure as well. So you can see I just did the same thing they did on the animation for number 2. So it says we're going to mark our given information on these figures. Let me get that out of the way. So let's mark what we know to be true on these. So you can mark these on your figures. Remember, we were given AD to be equal to BE. So you can see they put a tick mark on AD in both figures and BE on both figures. Okay, so you can do that on your notes as well. We're showing that CE AD. Let's do AD. AD is here, and it's here in the middle figure, is equal to BE, which is here in the middle one, and on this one on the right side. So I put one tick mark on AD, one tick mark on BE. We were also given CD is equal to CE. So we're going to, of course, use two tick marks this time because we're not saying they're congruent to the first pair. So here's CD in the drawing on the left, and in the middle drawing, there's CD. Now here's CE in the middle drawing, and the one on the right. Now notice we also have CE here on the one on the left, and CD here on the one on the right. So here's CECD, CECD, CECD. So I have two tick marks on all of those parts. Now that is the given information. Now in planning the proof, I hope you noticed that when we took these triangles apart, that they had a common angle. Angle C up here in the middle one is the angle C at the top of the left and at the top of the right. So of course angle C would be congruent to itself. So we can go ahead and put an arc in all these angle C's. They're all the same angle C, even though I obviously didn't draw it perfectly because they do not appear that way, do they? But they are the same angle C. So in our plan of attack, based on the given information, what of our postulates, which one of our 5 shortcuts do you think we're going to be using to prove these two triangles are congruent? So I hope you can see that we're going to have 2 pairs of sides and 1 pair of angles. And the angle is in between. We call it the included angle of the 2 sides. So that shortcut, that triangle congruence postulate that we should be using in this proof is SAS. So now we're going to actually go through and do a formal proof of this, proving that these triangles are congruent so that we can then prove the angles CEA and CDB are congruent. So you can write your formal proof on number 4. I'm going to put it in a 2-column format, and you can see that here on the screen. So we know what our first statement and reason is going to be. We're going to state our given that AD equals BE and CD equals CE, and that reason is, of course, given. Now, when we're looking at SAS, we, of course, know these sides are congruent because they have the tick marks, and we know these angles are congruent because they each have the arc. But wait, we need to show in our proof is that this whole side AC is congruent to this whole side BC over here. We have their parts as being congruent, but we actually need to show that whole side is congruent. So the first thing we're going to do is we're going to take these 2 equations and actually add them together. So we're going to add the left side of each equation together, so that would be AD plus CD, and the right sides together, BE and CE. And so what we are going to get is AD plus CD equals BE plus CE. And all we did was addition. We just added the left sides together and the right sides together. So that is step 2. And you can pause this at any time if you need to catch up writing. Now look at this figure. What is AD plus CD? Hopefully you see that those are the parts that make up that whole side. What do we call that whole side? Well, we can either call it AC or CA. It doesn't matter. But remember, we know that parts add up to a whole. We have postulates that tell us that. Anytime we talk about parts adding to a whole, remember those are addition postulates. We have the segment addition postulate and the angle addition postulate. But since we're talking about segments here, we would be using the segment addition postulate to say this part plus this part equals this whole. So our third step is going to do exactly that. AD plus CD equals AC. Part plus part equals whole. And we're going to do the same thing on the other triangle. BE is a part, EC is a part, and together they make BC, which is the whole. So BE plus C equals BC. And again, that's the segment addition postulate. Parts adding to equal the whole. Now hopefully you see what we can use with steps 2 and 3. Do you see we have AD plus CD equaling BE plus CE, but I know something else AD plus CD is equal to, And I know something else BE plus CE is equal to. Step 3 tells me AD plus CD is equal to AC. So I can replace AD plus CD with AC. I can also replace BE plus CE with what it's equal to, which is BC. What allows me to replace something with something that is equal to it? Remember, that is the substitution property. So my next step is going to be AC equals BC using substitution. Again, I just replaced AD plus CD with AC and BE plus CE with BC. So now I did prove this whole side is congruent to this whole side. Okay, so I have this whole side is congruent to this whole side. I was given this side is congruent to this side, but I have not put in my proof anywhere yet that angle C's are congruent. What tells me that angle C is congruent to itself? Remember, that is the reflexive property. So we need to have that in our proof, that angle C is congruent to itself by the reflexive property, and you don't have to put of congruence. Reflexive property is fine. So now we have this side congruent to this side congruent to this side, and this angle congruent to that angle. So with that information, I can now prove these two triangles are congruent by the shortcut we already said we were going to use in number 3, which is SAS. So my sixth statement needs to be that triangle CEA is congruent to triangle CDB using SAS. Now I can prove what I was trying to prove. Angle CEA congruent to angle CDB. And remember, following congruence of triangles, almost always we use CPCTC. The corresponding parts, which you have 3 angle parts and 3 side parts, are also congruent. So angle CEA and angle CDB are congruent using corresponding parts of congruent triangles, which are also congruent. So we have congruent triangles first, and then their corresponding parts are congruent. All right, so what does the reflexive property of equality tell us? Remember, it simply tells us that something is congruent to itself. So we just used it, angle C being congruent to itself. A lot of times it's a side that's congruent to itself. It's a shared side among 2 triangles. So it can be used to say 2 angles are congruent to each other because they're the same, or 2 segments are congruent to each other because they're exactly the same. So it's used a lot in overlapping triangles because of that shared part. They either share an angle or they share a side. All right, on your homework tonight, I just want to remind you of something that we've reminded you about throughout the year, but sometimes it just deems repeating again. So on your assignment 10.6, if you get a little confused about what's going on with problems 1 through 11, I just want to remind you that you can go to russellville.agilemind.com, use your username and password, and go to your geometry course. We're in topic 10. Those are along here on the left side. So go to topic 10 and your practice problems. If you go to guided practice number 1, do you see that looks just like what your problem is on your homework? And so you can flip through here. You can get hints along the way. You can try out answers. But remember, you're not just trying to get the correct answer. You want to have understanding, or it's not going to help you on a test. So getting just one correct answer on homework, whoopee, you got 1 homework point. But if you don't understand what's going on, then that's going to hurt you on a test. So always make sure that you go through and you understand, not that you're just going through to get correct answers. But I did want to remind you that you do have that resource at home. All right, good luck.